In this lab, we will be observing the forces acting upon a star as it is orbiting a black hole, using a computational model to derive the mass of the black hole from the component forces. And then, in a separate computational model, the value of the mass of the black hole was then plugged in to determine the initial velocity at which a spaceship would leave the orbit of a black hole and fall off the path with that gravitational force. And we found the initial velocity and the mass of the black hole listed in the slides. For the fundamental principles, we have force decomposition, which looks at the components of the force, the net force, and that will be the parallel force and the perpendicular force. And then momentum principle, which is also an equation for F net, is the change in momentum over change in time, which can also be written as final momentum minus initial momentum over time. These are all vectors, but we will be using the magnitudes of them in various locations throughout the code. And then we have Newton's second law in order to update the velocity and position updates. And we will also be using the gravitational force in order to determine what exactly the force of the black hole is on the surroundings. And so the actual system is the components that are a part of the orbit, the kissing circle as we will call it. And so either the spaceship or the star will have both an F perp and an F parallel. The F parallel is parallel to the motion that it is traveling in, and F perp is pointing in the direction of the gravitational force. And so for the initial condition of the first system, we will have a mass of the star. The delta time, which is just looking at the interval of time we will be using over the course of 24 hours, and then the gravitational constant, which is constant throughout the whole system. So for a star, the star will be the system and the black hole will be the surroundings for this. And moving further on into computational model 1 to look at what the mass of the black hole is, we will also be using delta V, which is V final minus V initial, and then we will be taking the p hat of the final momentum and using that to plug into our various components of our force. And so we need both the momentum and the velocity in order to figure out the position update and the F net update. And so to use the F net, we will be taking the parallel force and the perpendicular force and adding them together, which is seen throughout the code. And this will also give us the mass of the black hole because we can then manipulate that equation in order to say F net over the gravity of the star times the mass, which is a derivation of the gravitational force equation. And so, in using that computational model, we were able to arrive at the first value listed in this, which is the mass of the black hole, which is 8.5 times 10 to the 33. For the initial condition system of computational model 2, we will be using the mass of that previous black hole and plugging it into the next model. And so this will list the gravitational constants, the mass of the planets, the mass of the ship, and these will be the initial conditions. And the system will remain the same as the surroundings will be the black hole and the system will be the spaceship. And so we will be taking the force of the black hole and the radius of the planet to ship and the radius of the black hole to the ship, and we will be figuring out exactly how the force of gravity will be affected in order to derive what the velocity would be if it exited the orbit circle. And so, as we see, the initial velocity was negative 3.3, 10 to the 7th, 4.2 times 10 to the 6th. And this was derived from a method of guess and check and plug and check, as well as an estimation of how the forces would shake out. And so this would be the final initial velocity as close as we can get to what would exit the circle. For what does it mean for parallel and perpendicular to be equal? It means that the net change in momentum is the same as using the net force, because we were able to use that code throughout our programs and interchange the momentum and the net force equations for each other, just as long as we had the velocity and the net force updated as well. And for what if, we used a plug and check method in order to find the initial velocity if something left the orbit of a black hole.